So once you're comfortable with basic Ruby constructs, we could move on to something called metaprogramming. So metaprogramming is writing code that writes other code or writing code that manipulates language constructs at runtime. And Ruby is dynamic, very dynamic, in that classes and modules can be modified as the program is running. And it's metaprogramming friendly. It allows you to write code that manipulates language constructs at runtime. Is this magic? It might seem like that. But again, it's as you get more comfortable with the language, you could move on to this next level of programming in Ruby. Is metaprogramming a good thing? Some people oppose metaprogramming because it makes things harder to debug. But then again, if it's a level of comfort that the more comfortable you get with Ruby, metaprogramming just might seem like the next step. So one concept of metaprogramming is this idea called open classes. So the class keyword creates a new class, or it adds to an existing class of the same name, as we're going to see. And as we already saw, there's no method overloading a Ruby, because the latter method definition becomes the new definition of a method as opposed to being the second definition. So for example, you have a class called myClass that has a method called test that outputs test1. And let's say in the same class, later on, you have another method that's called test that outputs test2. When you actually instantiate the class, the myClass class, you get test2. This method became completely gone because of the second definition with the same method name. And then let's say somewhere later on in the program, you bring in this class called the same name, myClass, that has yet a third method definition called test3. That becomes the new test definition, the new definition of the test method, test3, and the first two are completely gone. So if a class with the same name is defined multiple times, it becomes a merge, right? So what we just saw is actually defining the same method. But if you define many methods in different files, but the class name is the same, it becomes a merge. And this is useful if, for example, you want to define class methods in logical groups. And what happens in this case is that the class keyword behaves more like a scope operator than a class declaration. So think of like math class, right? Let's say you want to define some methods in one area, but then you want to have a different file that maybe defines some trig functions or something, right? So both classes would be called math, but you would define different logical groups in different files, but they would still be under the same umbrella of a math class. And it's useful because you don't have to have one file, one class with gazillion methods in it. You have two small chunks, small files that deal with different logical groups of method names. So for example, you have myClass with one method. You have myClass maybe in a different file with another method. It becomes a merge. Both methods are available. You could have myClass one method, myClass another method. Now, not only can you modify and manipulate your own classes as you move along in your code, but you could also do the same with the built-in Ruby classes. There's no extra protection for the Ruby classes. And this practice is sometimes called monkey patching, sort of a derogatory name to it, but sometimes it's useful. But obviously you have to use extreme caution because you are modifying the actual Ruby language. So for example, you have a string class. You could pop open the string class and add your own methods to it. For example, you could have a method called really, or you could define the length method to always return 2. So then in your code you could say hi there, which is a string, and now it has a method called really, right? Yes, really. Or you could print the length of hi there, which somehow prints out 2. That just can't be right, because obviously the length of hi there is much more than 2. But the point is, you can do this. Now, it sounds like a crazy thing to do, and why would they even allow this? Because sometimes it's actually useful. So for example, let's look at a good example of monkey patching. You could introduce your own methods into the integer class. So for example, method called seconds, would just return itself, meaning the integer, and then the minutes would be 60 times seconds, and hours would be 60 times minutes. Okay, so now you could have time class, time now instance, which is an instance of time, and then you could say now, which is this, plus 5 minutes, now plus 10 minutes. The integer all of a sudden has minutes method on it that you could use, and it makes it very easy to program, right? So the variable is called in 5 minutes, now a variable called in 10 minutes, and then you could see this in 5 minutes, or whatever you want to call it. Is that in between now and 10 minutes? Yes, it is. And then you could actually print out the values for now, in 5 minutes, and in 10 minutes. And you could see how this is useful. And as we're going to see later, a lot of times Rails and the code associated with Rails makes use of this to make programming very much elaborate, and it makes it easier in certain cases. Okay, so the other thing you could do is methods that we've been seeing so far, like puts, for example, for printing things. So it turns out those are not just magic methods in the language. The puts method and some others are part of this kernel module. And this kernel module gets mixed into the object class, making the built-in functions globally accessible. Now, once you know that information, you could add your own methods to the kernel module for possibly better results. So for example, you could define a log method on the kernel module that basically takes in a message and prints out the time in front of your message. So now instead of saying just puts, which is the regular kernel method, you could say log, and that will print out whatever the message is with time in front of it. So now you got yourself this new method that you could use for your own purposes, and it could make things easier for you. Now, once we're talking about how modules get included, an interesting question here: does the order of module inclusion matter? So can including 2 modules that contain the same method name cause trouble? So the answer is, of course, yes, right? So let's say you have module 1 and module 2 that both have the method test, and you include module 2 and module 1 in this order, module 2 first and module 1. So which test method is it going to use? So you could always look at the chain of methods, the ancestors, right? So for example, one class in this case, which just includes the one module, its ancestors are going to be the one class, so it itself, and then one, which is a module that it includes, and then the object, kernel, and basic object. And then the 2 class is going to be the one module was the one that was included the latest. So it's going to be inserted right above the class, and then 2 and so on. So in this case, because module 1 was included the latest, it gets included all the way in the beginning. It sort of gets inserted in front. And what happens is when toClass is looking for this method called test, it's not part of a toClass method, and the module that it looks for next for that method is module 1. So when you actually use this method, you're going to get test 1 because that is the module in the hierarchy that is the next one.